know coming into level 2 physics now, like what is a wave?
Should know, but we don't.
For some reason I'm thinking of Purple Monkey.
Yeah.
Things that we should know but we might well not know about waves. And so we're going to start by sketching down a little diagram of what, as a physicist, what we mean when we say a wave. So we're going to have an axis, which
Wait, are you recording?
and an axis which is like that, and a wave, it's like if you go and take a photo of the sea, right? What you see is that as you look at that photo, the water goes down.
Waves.
Sort of like that. And so, thinking about what do we mean, it's a photo of water, like frozen in time. If you've taken a photograph, that means you've stopped time. The x-axis is like the position on the water, the position on the medium. And the y-axis, we're going to have this maybe new word for some of you, which is the displacement from the equilibrium. Equilibrium, like where would the water be if there were no waves? It would just be flat along that blue line. And so the y-axis is the displacement, like how far is the surface of the water moved from that equilibrium.
If there was no waves,
Yeah, there'd be no waves.
that'd be cool.
Technically it'd be a lot of
Unless it's
It would just be a fat mirror.
because the length of the wave would be 0. It'd be really short.
And so both of those axes are measured in meters, and we can label some important. That's good. We can label some important parts of the wave. So what? Thinking water waves. What do we call the top of a wave?
P.
So that's what C.
The cat.
Stop the cat.
Con on.
And roosters have them too.
Crown.
Care to finish that for us?
Chris,
Chris.
Yeah.
Yeah.
That was my second guess.
Crown.
Roosters are. I'm glad we got that on recording, by the way.
Oh yeah, I'm recording.
It is.
Right.
Uh-oh. Oh, I need to check.
Crest and trough are the names for those two parts of the wave, and the name for the distance between the equilibrium position
I was
and the highest point, or it could also be the lowest point on the wave, is called the amplitude. Amplitude, like the height of the wave. Also measured in meters. So the height of the wave is the amplitude. The new symbol for the day that we have to learn is for measuring the wavelength of the wave. And wavelength is from one point on the wave. You can see how it's a repeating pattern that's going on here. It's from one point up until where that point is repeated. So an easy way of doing it is from one crest to the next crest. Wave length. We're thinking length. So we're thinking a distance. It's the distance from that part to that part. And the symbol we use, Greek symbol lambda. It looks like that.
What? Wait, what's that? What's that mean? Wait, what is it called?
Let's just redo that.
So that symbol is called a lambda.
Oh, Namba.
Lambda.
Namba. Why is everything in?
That's what it's measured
measured in
in.
meters.
Oh.
Because both of our axes, one of them is displacement from the equilibrium position, which is measured in meters, and the other one is position on the medium, which is also measured in meters. You recording on your phone?
Yeah, I'm recording.
On the front.
I'm recording,
I'm sorry,
sir.
Recording.
Alright.
That's the question.
And so that was what do we see if we take a photo, if we freeze time, what do we see? The other way of thinking about it is if you get your little boat and you row it out into the water and then anchor so that you're at a fixed position, but you're sitting on that boat and time is moving, but you're not moving because you're anchored. Just thinking about what do you experience as those waves go past you.
You did
So we can do a very similar picture for that. We can have the same, exactly the same y-axis displacement from
Yeah.
equilibrium position.
Sorry about it.
But on our x-axis, we're talking about time in seconds. And the graph looks the same. If you're out there in your little boat, you go up, and then you go down.
That's kind of
And you
scary.
go up, and then you go down. And I've done it in green because that's the colour you'll turn if you spend too long out there in your little boat going up and down.
Nice.
Shit.
Where's the BRI?
I think we should test that.
Which word are we looking at? Equilibrium.
Yeah.
E-Q-U-I-L-I-B-R-I-U-M.
What's the next
Hang
one?
on, spring.
Position. P-O-S-I-T.
I just can't see the S.
Yeah. It's do be kind of hard.
And so most of our markings on this graph are the same, but what are we going to be measuring now if we measure from one crest to the next crest?
Time.
The time and the word we use for this when we're talking about anything that's repeating, like because it's a repeating waves are a repeated thing going over and over and over again, is almost is period.
Period.
Time period.
That's very similar.
What's the
In
difference?
seconds. So the period is the time for a motion to repeat itself. Let's
So push it.
make some little definition-y things. So period is time for motion to repeat itself, which is very, very close to what Momo said. Frequency is how often a motion repeats itself in 1 second.
And periods like the time it takes to repeat itself.
Exactly.
Oh,
So
no.
these are very closely linked. They're so closely linked that you'll see on your formula sheet that T is equal to 1 over F. Period is equal to 1 divided by frequency.
How often?
So T stands for time period, measured in seconds. And F stands for frequency, measured in hertz. Hertz, Hz, or seconds to the power of -1 per second. Because we're talking how many times. So when we're talking waves, for frequency, we're thinking how many waves pass a fixed point on a media in 1 second. So 4 waves, how many waves pass a fixed point on a medium in 1 second. And period, time for one wavelength to pass a fixed point. I reckon once you've got that, you can probably stop on your weak water. I have this terrible sinking feeling I forgot to make you guys a homework, so just give me a 1 minute chance to make you a homework because we need to do one at a fraction.
So you still
Exit.
Yeah, I'll stop it.